let's look at the most commonly measured properties of crude oil. Specific gravity, or API gravity, viscosity, color, and odor. In the marketplace, crudes are classified by density and sulfur content. Density is measured in degrees API. Light crudes typically are easier to process than are heavy crudes. Sulfur content is measured as a percentage. Crudes with less than 0.7% sulfur content are considered sweet crudes. Crudes with greater than 0.7% sulfur content are considered sour crudes. Acid content is measured by total acid number, TAN. Crudes with a TAN greater than 0.7 are highly corrosive to refinery equipment. What is density? Density is the weight divided by volume. Specific gravity is a dimensionless number which is a measure of the density of a substance compared to the density of pure water at an arbitrary temperature and pressure. As such, we measure the weight of water versus the weight of crude oil. Measurement of density is defined by the American Petroleum Institute. API fixes the specific gravity of water at 1 gram per cubic centimeter. According to the API gravity scale, specific gravity equals 141.5 divided by 131.5 plus degrees API. Specific gravity can be measured with a hydrometer. API gravity is equal to 141.5 divided by specific gravity at standard temperature and standard pressure minus 131.5. We can also measure API gravity with a hydrometer. In fact, lease operators typically every morning measure the API gravity of the oil that's being produced from a well. The specific gravity of water is equal to 1. Thus, because oil is lighter than water, the specific gravity of oil is usually less than 1. The API gravity of water is 10. Thus, because oil is lighter than water, the API gravity of oil is greater than 10. Crude oil can be described as light, which is greater than 31.1 degrees API, medium, which is between 22.3 degrees API and 31.1 degrees API, heavy crude oils, which are less than 22.3 degrees API, and extra heavy crude oils, which are less than 10 degrees API. Viscosity is a word used to define a fluid's resistance to flow. For example, water has a higher rate of flow than the rate of flow of honey. This is a picture of motor oils of different viscosities. The viscosity of crude oil varies from field to field. For crude oils of like chemical composition, viscosity increases with decreases in API gravity. Temperature also affects viscosity. The higher the temperature, the lower the viscosity. Dissolved gas can affect viscosity. The effect of solution gas is to reduce viscosity. Pressure has an effect on viscosity. For most liquids, viscosity increases with increasing pressure because the amount of free volume in the internal structure decreases due to compression. Consequently, the molecules can move less freely, and the internal friction forces increase. The result is increased flow resistance. Above saturation pressure, viscosity increases almost linearly with pressure.